All right, let's look at a basic, sort of basic, uh, alteration or transformation of a cosine wave, right? So cosine waves, the alterations that we see in a cosine wave are going to be the same as in a sine wave, right? The amplitude, the vertical shift, the period length, the alteration of the period. The difference is the location of the points, right? The pattern of those critical points is different in a cosine wave. So, we'll go through this one time real quick, and then we'll look at it on Desmos. The floating constant is the easiest part to identify. That's our vertical shift. Okay. So we know when we're outside the original function, we move logically with according to the values that we see. In other words, this is a positive 3, so we're a vertical shift up 3 units. And mentioned this a couple of times, but the vertical shift is important because it moves the midline. Okay, so that balancing line that cuts through the middle of a cosine wave, right? So basic cosine wave starts at its maximum, then an intercept of the midline, then the minimum, then the intercept of the midline, and then the maximum. So we have the midline here at the of the x-axis. So this graph is going to take that midline and it's going to move it up 3 units, which means each one of these points is going to move up 3 units. So now we're here, okay? The amplitude is the coefficient, right? Now, notice I'm leaving out the negative. We'll deal with that in a second. The amplitude is always a positive number, okay? So the amplitude here is 2. That takes the entire graph and it stretches it. Now, if we're stretching this graph by a factor of 2, okay, we're taking these points and we're stretching them up off of the midline. Think of it this way. So the points that are on the midline actually stay there, okay? The points that are off the midline, think about amplitude. We said it's the distance, it's half of the distance between the max and the min. That's the textbook definition for amplitude. The other definition would be the distance between the midline and the max or the min. So right now, that distance between the midline and this maximum is 1. When we increase the amplitude to 2, this point is going to move up to a distance of 2 units away from the midline. This point's going to move down to a distance of 2. This point's going to move up. So I'm going to come through here like a surgeon and just kind of take out these pieces right here. So now we're looking at a sine wave with critical points right here. The last thing on the outside of the function is we have to be cognizant of this negative sign, okay? If a is negative in the function, we have a reflection over the midline. So again, points that are on the midline don't move. Points that are off the midline reflect over the midline. So this point, instead of being 2 units above, it's going to be 2 units below. This point moves up to here. This point moves down to here. Again, we'll come through and get rid of these. So there's the reflection. Okay, so a normal sine wave starts at its max, goes to its intercept min, intercept max. This graph starts at its minimum because it's been reflected over. We're going to see some of that in our harmonic motion problems later on as well. Okay, inside here, what we see, right, is our phase shift. We take all of this together. Now, B in this case is 4. And we know that the value of B affects the period according to this ratio. So in this case, we would say 2 pi over 4, which is equal to pi over 2. So again, let's talk inside-outside transformation, something that's happening inside the function. It's opposites day. Normally, if we multiply a value by 4, we're increasing the overall value. We're getting a larger product. Inside the parentheses, we're actually compressing the product. Okay, so in this case, the wave. So what that means is this cosine wave, which normally would start at 0 and the period would end at 2 pi, this entire wave is going to go through that progression of min, intercept, max, intercept, min by the time we get to pi over 2. So if this is pi over 2 is right here. So we've basically compressed this graph to starting here and ending here. So we end up with a cosine wave like so, okay? Instead of what it should have been, which is right here. Okay, so we've squeezed from the sides. That's our horizontal compression. There's no horizontal shift. So the phase shift here, if you want to consider it, C would actually be 0 here. So the phase shift would be C over B. That's 0 over 4, which is 0. So we haven't actually shifted the starting point of this first period. It is on the y-axis where the cosine graphs normally start. Okay, so let's look at this in Desmos. I added some sliders here this time. So we said D was 3, I believe. Oops. We said A was actually -2. I know amplitude is not negative. Maybe I should zoom out here so you can see how this works. So like when we transform A, the amplitude, watch it flip over. Bloop. Okay, so now we're at -2. B was a value of 4. Watch this slinky action. See how it compresses, okay? And C is 0. So when C is 0, that first critical point of cosine or sine, right? For cosine, it's a max, but this is a min because it got reflected over. That's going to be on the y-axis. If we see that point shift off of the y-axis, that's an indication that there's been a phase shift in the graph, okay, in the function. All right, got some fun stuff to play around with this coming up in student Desmos here in the following activity.